Welcome back. While Python's reference counting is efficient, it has a limitation. It cannot deal with circular references, where two or more objects refer to each other. To handle these rare but important cases, Python uses a secondary generational garbage collector, which we can interact with using the standard library gc module. 1. Importing and enabling gc. To use the garbage collector's methods, we first need to import gc. By default, garbage collection is enabled. You can check its status using gc.isEnabled, while you can manually disable or enable it. 2. Forcing garbage collection. The method gc.collect manually triggers a collection run immediately. It forces Python to look for unreachable objects, primarily those involved in circular references. This method returns the number of objects successfully collected. You may use this function for debugging memory issues or for performance optimization in resource-intensive sections of your code. 3. Inspecting reference count. While not directly in the gc module, the sys.getrefcount function is crucial for understanding how reference counting works. It returns the current number of references to an object. Note that it will always show a count 1 higher than expected, because passing the object to getrefcount temporarily adds one reference itself. To summarize, Python's garbage collector usually runs automatically, but the gc module provides manual controls and inspection tools. Before an object is collected, there's one last chance to perform cleanup operations. This is done using a destructor which runs just before the object is destroyed. The destructor, defined by the __del__ method, is the final method called on an object before it is fully destroyed, making it ideal for final cleanup tasks. Join me in Lecture 16.15. Use destructor. See you there.